And this is 3.3 number 40, and the y as a function of x. Sometimes I just write y, and I remember afterwards to put the function in just to kind of remind you that it is a function of x. Y as a function of x equals x to the third. And at 40, we want to find the x and y intercepts of the line that's tangent to the curve, y equals x to the third. So we just want to find the tangent line. We've got our point of tangency, -2, -8, so that's nice. And we just want to find the slope, and our x value will be -2. So we can find the slope by taking the derivative, and we'll just straight ahead use the power rule. So we get 3x squared, so y prime of x equals 3x squared. So the slope at x equals -2. I just substitute -2 in here. And 3 times -2 squared, which is 3 times 4, which is 12. So my slope is 12. So my slope is 12, and the point they already gave me was -2, -8. So I just substitute this in my good old point slope form. Y minus y1 equals m times x minus x1. You can never write that down too many times because that's one of our most valuable tools. And I substitute. So I got my m, my slope goes here. This is my point, this is my y minus y1 equals m times x minus x1. That's just y plus 8 equals, and then 12x, and then plus 2 times 12 is plus 24. Subtract 8 from both sides, and this was the tangent line. And they wanted the y-intercepts and the x-intercepts, so when x is 0, I have the y-intercept. If I put 0 in here, y equals 16. So this was the x-intercept, 0, 16. I'm sorry, the y-intercept. When x is 0, that's the y-intercept. So y is 16. And if I want the, that's the y-intercept, pardon me, y-intercept. And the x-intercept is when y is 0. So if I put 0 in here and I subtract 16 from both sides, I got 12x equals -16. Divide by 12, and I get x equals -16 divided by 12, or -4/3. So that's the x-intercept. When y is 0, I have the x-intercept. When x is 0, I have the y-intercept. And that's all they asked for. So I hope that makes sense.